Chebychev theorem says there are at least 1 minus 1 over k squared of the distribution lie within k standard deviation of mean, which means if you know the mean and standard deviation of the distribution, then you can use this theorem to roughly estimate the proportion of distribution lie within a certain number of standard deviation of the mean. When the k is 2, that means there are at least 1 minus 1 over 2 squared of the distribution lie within 2 standard deviation. So 1 minus 1 over 2 squared is 3/4, which is 0.75. That's 75% or 0.75 proportion of the distribution. This would lie within 2 standard deviation of the mean. So this theorem can be applied in two ways. So if you know a certain number of standard deviation, you know this k, then you will know at least what proportion of distribution lie within that k standard deviation. In this situation, is 2 standard deviation of the mean. Now, what if I know the percentage first? I want to find out in how many number of standard deviation of mean that will have at least a certain proportion of distribution in that range. So if this proportion is given, we can set this expression equal to that proportion, solve for k to find the answer. Now, let's see this example. If you want to find out how many standard deviation of mean can we have at least 36% of the distribution in there. Chebychev theorem says at least 1 minus 1 over k squared distribution lie within k standard deviation of the mean. All right. So here the 36% will be the 1 minus 1 over k squared. And now if I solve this equation for k, first of all, I will actually subtract 1 from both sides and multiply -1 on both sides, right? So I get this. And then if I multiply k squared on both sides and divide 0.64 on both sides, I get this k squared is equal to 1 over 0.64. And I take square root of both sides of this equation, I can solve for k. K is square root of 1 over 0.64, which is actually 1.25. So we got it. Now if you want to find out within how many standard deviation of mean can we have at least 36%, that k is 1.25. So we will have at least 36% of the distribution lie within 1.25 standard deviation of the mean of that distribution. Now this can be applied to any distribution. So if we have a distribution, for instance, age of a population, that has a mean 50 and standard deviation 10, then at least 36% of distribution would lie within 1.25 standard deviation of the mean in this distribution. So that's 37.5 and 62.5. So how can we get this? That's actually read the mean minus 1.25 standard deviation. So that's to the left of mean. And also 1.25 standard deviation to the right of mean. So in that range, within 1.25 standard deviation of mean, we have at least 36% of the distribution. So this theorem can be applied backward. Now if I have a distribution that has a mean 50, standard deviation 10, and I want to find out at least what proportion or what percent of the distribution will be within 37.5 and 62.5. First of all, I will find out these two endpoints, there are how many standard deviation away from the mean. All right, so then I can apply the Chebychev theorem because that's going to be my k. So I can apply this formula to figure out what proportion. So what is the k here? The mean is 50, so the distance from mean to the left endpoint, 37.5, is actually 12.5. Divided by 10 is 1.25. Same thing, 62.5 distance to 50 is 12.5 divided by 10, that's 1.25. So both of these endpoints are 1.25 standard deviation from the mean, so that's a k. We try to find out what proportion of the distribution lie within that 1.25 standard deviation of the mean. The k is 1.25, so we just plug this 1.25 in for k in this formula. 1 minus 1 divided by 1.25 squared, this quantity. 1 minus this quantity is 0.36. So we got our answer solved. So we got our problem solved. There's at least 36%, right? The distribution that would lie within 37.5 to 62.5 because both these points are 1.25 standard deviation from the mean. Now Excel can help you to calculate some of the numbers. For instance, if you want to do square root of 1 over 0.64, you hit equal and then do SQRT, that means square root. Apply the square root function to a number. This number could be an expression, so that's 1 divided by 0.64 and close parentheses. So that gives you the square root of 1 over 0.64. That's 1.25. Okay. You can use that also help you to find out 1 minus 1 over 1.25 squared. You use the shift and 6 key. This gives you the 1 minus 1 divided by 1.25 squared. So it'll do the 1 minus 1 divided by 1.25 squared first, right? Based on the order of operation. So this part will be down first. And then once subtract this number. So if I hit enter, I get the 0.36.